Humans of Earth, welcome to Will AI Snap That? My name is Michael Rollins, and I am joined as always by my co-host Thanos, he of the Snapdom. And we are here today to tell you about how AI is going to take over the skies. We are joined by Adam and Chris from Savvy Aviation. And Thanos, I will let you take it from here, my good friend.
Well, hello, everyone. I have been working with Chris for over 15 years, I believe, and Adam a little less than that in a company called Savvy Aviation that helps owners of small aircraft with their maintenance issues. So why don't we start with Chris? Chris, tell us like a little bit about yourself and what you do at Savvy, and then we'll move over to Adam.
Okay. Yeah, I'm Chris, and I'm Executive Vice President of Savvy Aviation. And Savvy, basically, its primary mission is to empower aircraft owners to really take control of their maintenance. They have the regulatory responsibility for it, so we try to teach them how to do it. You don't really learn that when you learn how to fly, so we help with that. I have sort of general management responsibilities at Savvy, but mostly I work on analytics. My background's as a statistician. So I did some of the early machine learning work that we did at Savvy. And Adam does most of that now. But anyway, that's the area that I'm involved in.
That's awesome. And if I remember this right, you have some hardcore PhD in like operations management or something like that.
Yeah, well, statistics and operations research.
Does that mean I can call you Dr. Chris the whole episode?
You can if you really want to.
Dr. Chris, tell us now.
Sweet. Adam, how about yourself?
Yeah, I don't know if you knew this. It's actually a requirement to be on the Savvy analysis data science team that you have to have a PhD in something. Yeah, so here we go. I'm Adam. I've been at Savvy, I think, since we started in 2021, Chris, when we started working together, and it's been an exciting adventure. I'm also a flight instructor. I teach sort of part-time, and I have a background in physics, and I worked in the semiconductor industry as well for a while, and found my way to Savvy after I really got into reading stuff that they were writing and creating, and I think it's an awesome company and interesting place to work for. And I deal with airplanes every day, so it's beautiful. It's a beautiful existence.
I think.
Yeah, so, and that would make you Rollins the only one here without
I was going to
license,
say, not
so
only am I
to
the
fix
only
that.
one without a pilot's license, I think I'm also the dumbest person in the room now. Because we already know Thanos is smarter than me.
But you can probably fly drones better than all of
this
us,
is
so
true.
that's something.
I can probably fly a drone better than any of you. But I used to do the FPV with the goggles and, full acro, and absolutely a blast. Also expensive and very maintenance heavy. I don't know. Did you guys know that things that fly require a lot of maintenance?
Well, we argue that they require a lot less than
right.
Probably right.
Most people think.
I am 100% certain that the rate at which I crashed my drones was responsible for the extraordinary amount of maintenance they had to have.
That could be.
It's a lot of wear and tear,
Yeah, so let's jump in, because I think people may be wondering, so what the heck does aviation maintenance have to do with AI? And I think initially there's a bunch of stuff that we have done at Savvy related to machine learning. So maybe Adam, Chris, you want to kick it off and tell us a little bit about how this whole thing started. Chris, you probably have insight on further back this goes with Viva 1.0 and talk about the evolution there to Viva 2.0 and so on.
Well, sort of as part of our mission to, empower aircraft owners and maintenance, we also have sort of a strongly held value and Savvy that you should only do maintenance, what we call on condition, meaning that you don't fix stuff unless you know it's broken. And so how do you establish condition on an aircraft? Well, the old-fashioned way is with a flashlight and a mirror, a lot of inspection. But, recently, starting 15 years ago, we started to gather all this data in the aircraft itself. And that data is available for download. And what we're trying to do is use that data to help understand the condition of the aircraft, condition of the engine, so that we can support the maintenance function with it. And that's how I met Thanos, because Thanos was the one who built our platform that gathers that data and presents it to the pilot, allows our analysts to look at it and do their work.
And how does that work? Do you literally like stick a USB stick into the airplane and you get data?
Thanos, I don't know how it works because I don't do that part of it. Yeah. The instruments, you generally have an SD card. They're mounted on the panel, kind of small instruments, and have an SD card. And you take that SD card out, you put it in your computer, and you upload it to Savvy Aviation, and you could archive it there, the data, and look at it, view it, do some analysis yourself. And you can, if you're a client of ours, you can request us to have an analyst look at it and help. And then the machine learning works in the background and kind of examines the data and tries to flag things. I'll let Adam explain more of the details of that, but try to flag things that need attention.
Yeah, our features run the gamut of kind of basic statistics. So we generate statistics for every what we define to be cohorts of aircraft. So if you have a specific type of airplane with a specific type of engine, it might fall into a specific cohort. And then you could get basically the two basic statistical features are report cards and what we call report cards and an analysis of any trends that might be appearing in your data. So we determine if trends are statistically significant. And then separately from that, if your engine is a little warm on average, you'll see a score reported to you on a regular basis or on demand compared to all the other airplanes that are similar to yours. And you can kind of see how it stacks up. And there's some kind of assessment capabilities there as well. But into machine learning, Viva, which I think you guys mentioned Viva already, it looks at engine.
What does Viva stand for?
Yeah, the failing exhaust valve analytics is, I think, analysis. It's either analysis or analytics, but one of the two.
Or algorithm.
Yeah, it's become a dictionary. It's just become part of the lexicon at Savvy, but just Viva itself. But anyway, when clients upload their data, we can determine whether or not it has a cruise segment, a long period of time when they're just kind of flying level from A to B, which is the majority of any traveling part of the flight. And we look at, I think it's 34 or 35 parameters that are determined from that data. And we use that to feed into a machine learning model that predicts the likelihood that any of the 4 to 6 exhaust valves inside of the piston engine are in a state of burning, or what we call heat distress, I think is the more appropriate term at this time. But we report those scores on a weekly basis based on customers who upload data, and they see kind of a recommendation on which cylinders of their piston engine they should look at with the borescope, for example, to determine visually if there's any heat distress on the valves.
And that is a very common failure, as I understand it, right? So it's a large number of planes exhibit this symptom, and if you let it progress, kind of bad things happen.
Yeah, it could result in kind of a catastrophic situation if there's sort of an extreme valve failure event. It could shut down a cylinder, for example, depending on the situation. And that would not be fun for a pilot to experience or the passengers. But in terms of likelihood, it's around 1% to 2% valves that we see borescoped have symptoms of heat distress. So it's not exceedingly common. And typically it's not really the fault of anything that the pilot has done, which is sometimes perplexing for pilots who are customers who tend to really be interested in their data. Yeah, it's not super common, but it does happen. Yeah.
So real quick, stuff I want to ask if Savvy has a Viva for more cowbell. Beyond that, Dr. Adam got it. Dr. Adam.
Yeah.
I totally missed it.
Yeah, no. Who was the guy? I got a Viva, and the only subscription or the only prescription
Will
is more
Ferrell.
cowbell
Right.
from SNL.
Yeah.
Okay, so I have perhaps once or possibly twice in my life seized a piston on a vehicle. And it was this Jeep that I had, this beautiful, terrible CJ5, 79 CJ5 something. Wish I still had it, but I don't. And after the piston seized, the Jeep didn't go. It decided it wanted to sit exactly where it is. Is that is that what happens if a piston seizes in an airplane, or is it different?
It sounds more like a stuck valve to me, which also does happen occasionally. But that Jeep probably only had 4 cylinders.
I had
It's
6.
at 6.
It ran very
In an airplane, yeah. If
Okay.
you have a stuck valve in an airplane, for example, it could bend a piston or shatter the piston, or bend a push rod or shatter the piston or something like that. So there could be a pretty significant mechanical failure. So if you have
Okay.
4 cylinders and only 3 of them are working, or 5 cylinders out of 6, it could be a real
Yeah, in this
big
instance,
deal.
Usually
well, go
a
ahead.
seized piston usually a seized piston is a lack of lubrication.
Mhm.
So you somehow lost lubrication on that. Just basically welded itself together.
The temperature gauge wasn't working on the engine, and it got hot enough to swell the piston. It was bad. It was real bad.
Ouch.
A different problem.
Well, so the nice thing about Viva is that it can figure this out, figure out the signs of distress with tens of hours before the event actually happens.
Okay.
So it's been a super nice improvement as a tool in the customer's toolbox of being able to do that. And Viva, the current version of Viva that we have is based off all these parameters that Adam was talking about. I think the original Viva was much more of a programmatic model where it just looked at a specific pattern. It wasn't really even ML or statistics in any way. It was very like imperative, like just look at these systems and figure it out. So Viva 2 is like super sweet because it does all this extra analytics. And Adam, tell us, I know we've taken this and then we've taken this a bit further with doing other engine analysis as well, because we have all this wealth of information in millions of flights that are now in the database. So tell us what is coming after this, and what are other exciting more ML type things that we're doing.
Yeah, I mean, the current focus is on developing kind of a generalized anomaly detection system for all flight data that is uploaded. So a customer, like you said, I mean, Rollins, it probably is once the pistons stopped moving in your Jeep, you probably noticed, right? Yeah.
That's bad.
And yeah, I mean, once something like that happens in an airplane, typically it's a kind of a big deal. But what we want to do, Thomas, like you mentioned, is let the customer know beforehand so they can do something about it. And that's the whole purpose of this generalized anomaly detection system. We call it GADFLY. There's actually an article that came out in AOPA magazine recently, I think it was this month, where Mike, the founder of the company, co-founder, I guess, writes about the system and how it works. But yeah, fair enough. So something happens in an airplane that might be too minimal for a pilot to detect necessarily, but they upload the data and then they receive a ticket or a notification of some kind saying like, hey, we saw this in your data. GADFLY alerted us to this problem. The genesis of this idea was that, like you said, we have a lot of data that gets uploaded, and it's so much that an individual analyst can't keep up with all the data that, can't go in and look at every flight, determine if there's ever any kind of tiny problem. But, a system that automatically scans every flight and looks for anomalies and determines if they're significant enough to report, that's a little bit more realistic. And then it can alert the analyst to something basically in terms of priority, look at this first or look at that first. And so we can be more proactive with our clients, which I think they would appreciate. So that's the general goal with that service.
How often does
Nice. And can you give us some idea of what are the different inputs that we have? Like, what are the sort of data that the airplane gathers? And then what are like some examples of things that we consider anomalies? Like this happened and it's interesting to go look at.
Sure. Yeah. So in terms of, maybe it makes more sense to answer those questions in order. So, an engine will report various data if it's installed with something called a digital engine monitor, which
that was my question.
We heavily emphasize the use of these tools in airplanes now because of the diagnostic value alone. So when you take your car in, for example, they plug something into the ODB part of it, plug a computer into the car and they can see all the voltages and pressures and temperatures and blah, 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 all the things that are determined by the computer on how the engine is running. And this is exactly the analogous situation, except the pilot can see it all the time during operation. So for example, a piston engine runs on lubrication systems, ignition systems, a propeller that is spinning at a certain RPM. There's an intake manifold that has a certain pressure. So all of these data are recorded. So temperatures, pressures, oil temperature, oil pressure, and various other parameters like that. Anything that you could think of when you think of what you would measure in a piston engine and how it works, down to, it gets pretty complex. Fancy airplanes that come out that are very much in the digital age. They have all kinds of additional parameters. They measure the pitch of the aircraft and the roll of the aircraft, and all kinds of GPS data and things like that. So it gets pretty fancy. But what we're doing is we're ingesting that data and we're looking at deviations from the norm, essentially. So the model is trained in an unsupervised way, and it just kind of learns the patterns in the data. And if a data point is outside of a pattern, very rudimentary, speaking in a rudimentary way, it presents as anomalous. And so that can reflect problems with sensors, if it's just a plain old sensor failure, or it could be something more significant, like a mechanical problem or something like that, that would be manifested in multiple channels of data.
Sweet.
So one of the questions that we've talked about AI for a couple generations at this point, right? I remember hearing about it when I was a kid. And I think the generalized idea of AI came up really quickly in terms of computer science, right? They had finished Colossus, and not a few years later, they're talking about, Turing's talking about AI. How do you determine if an AI is intelligent, right? That's where the whole Turing test came from. Over the past couple decades, machine learning became a thing, right? Machine learning became like, oh wow, machine learning. And couple years back, I worked at a machine learning company. It was anomaly detection, and we would take time series data from just about anywhere and point out, hey, there's not only an anomaly here, but we think it's related to this. We would do some basic root cause analysis. And the idea was, there's signals in your data that are there and are important, but you might not be seeing them, right? And machine learning is really good at that kind of stuff, right? And then you got LLMs, large language models, which are not good at that stuff, right? Where they might just outright lie to you. So can you talk about how you see the differences in machine learning versus LLMs? I know that machine learning is involved in some of the training and things, but why is machine learning the right tool for this versus something like an LLM?
Chris, you want to take that one?
Well, I'll take a shot at it.
Sure.
LLMs we tend to think of LLMs now as AI, right? That's what people think of when you talk about AI. But, they're only a small segment of AI. I mean, they're basically text prediction models. And you can extend that to other things rather than text, but pretty much they're text prediction models. So, I think of machine learning as more of the sort of ability to predict other kinds of events that aren't really textually based. Oh, and I learned something really interesting, which was, as you guys know, AI that has gone through ups and downs over the years, like we talk about AI winners and things like that. Well, apparently at one point it got to be such a dirty word that the people that were working on it didn't want to use the term, so they invented the term machine learning.
Oh,
instead.
really? Okay.
Yeah.
That
So,
makes sense.
That's
I've
funny.
never even
Yeah.
thought about that, but it does make sense. Was that around
Yeah.
the time
So,
that
anyway.
neural networks became the thing?
Yeah, and as you guys know, that the guys that worked on neural networks were like outcasts for years. Now they have Nobel Prizes and Turing Awards, but they were the guys over there who were working on stuff nobody wanted to work on.
Yeah.
So
Yeah, they also have private jets now.
yeah. I don't know, Adam.
Yeah, but it's interesting because we oftentimes will use the two in combination, right? So I know, Adam, you and I are working on some gadfly stuff, and you use the machine learning to do some of the heavy lifting, and then you can use the LLM part to communicate some of that to the user. So that's sort of quite interesting of how they each have different applications, but they sort of can collaborate in a way to get some interesting results.
Sure.
Now,
Yeah.
the other thing that we're working on now is very different, but it's a machine learning problem, which is we started about a year and a half ago. Thanos built a platform that clients can upload borescope images. So the borescope is like a little camera that you put inside. You feed into the spark plug hole and you look around in the cylinder and take pictures. And you can upload that data to Savvy now, and we'll analyze it for you. But what we're doing is we're looking at these exhaust valves, and we're generating an entire set of data with valves that we look normal and valves that look like they're starting to be heat distressed. And we've now gathered enough of these that we've put together a fairly good classification model so that we can just show the image to the machine learning model, and it'll make a prediction of whether it's a heat distress valve or not. And our accuracy on this, the recall on this is about 85% now. So if we show it an image that an analyst has determined in their judgment looks like heat distress, the model will catch it about 85% of the time. So we're getting there, I mean, hopefully that'll improve as we get more data.
That's super sweet. And then what is interesting is that in addition to all this sort of numeric and visual data, we also have other kinds of maintenance data. We have all these files and maintenance logs for the aircraft. So you want to talk about thoughts there on how that could be made very exciting, because we have these for thousands of aircraft. And not only can you see like how the plane was flying, but you can see what maintenance was done on it. And I think the LLMs can be hugely useful there, looking through like a PDF of information of what was fixed on an aircraft.
Yeah, so I mean, I think that's where the LLM becomes very useful, because a lot of this data that we have on maintenance records is textual, and some of it's even handwritten textual. And, as these models get better and better at deciphering that stuff and categorizing it and putting this unstructured data into structured format, we compare that with the engine data. And, now we have an even more powerful way to help people with their maintenance, maintenance. But that, that's still kind of in the future for us. That's sort of our next step.
It's an exciting piece. So before we move to more futuristic stuff, is there anything else that we're doing or have done that we didn't cover that we should talk about?
Well, there's one thing that Adam worked on a bit when he first started with Savvy, but
Oh yeah.
it's a tough problem. It's these valves, they can either be heat distressed, or another thing that they can do bad is get stuck. And
Right.
it's called a sticky valve. And sticky valves have some symptoms before they start really causing a problem. And we would like to put together a machine learning model to predict sticky valves. It's tough because the symptoms disappear pretty quickly after you start the engine. And when you just start the engine, the data tends to be kind of weird. So you're really dealing with weirder data than we have been in our other kinds of models.
Yeah, it's a good point. I mean, that would be, the sticky valve project, I think, would be a good candidate for something like an application from anomaly detection, which we're currently working on. So I'm hoping that as we make progress with that, we can kind of apply like more of a targeted model towards those specific symptoms that Chris mentioned that appear that the customer may not be aware of necessarily, or may not know what to look for.
Yeah, I mean, looking at that data, it's pretty rough on startups. So if anything can make sense of it, some form of machine learning or AI should get in there.
Yeah.
So the whole industry here is quite straightforward. One of the things that Rollins and I usually do is we talk about how AI is going to sort of eliminate or drastically change a particular set of industries. And in this instance, it doesn't seem like this is taking over anyone's job. It doesn't seem this is blowing up like the whole industry, but it does seem that it's able to take out, it's going to be able to do some things that we weren't able to do before because there's too much data to look for. And it's also able to help like analysts and other people that look at this kind of data focus on more high level stuff, right? They don't have to look at every image to see if it's burned. They can get the AI to do that for them, and then they can focus on the bigger picture. What's your overall thoughts on where this is going?
Well, I had
take a question.
Yeah, I had some thoughts about that one. I would break it into at least two categories, maybe three. So the third category really is basically what we've talked about, where we're looking at the raw data and making predictions based on specific things that we're trying to identify, either anomalies or the heat distress exhaust valves, the sticky valves, and so forth, and the statistics. But then separate from that, using these large language models and other technologies kind of either inside the airplane or inside the hangar, to do very specific things. Like, for example, imagine, something that was available in your aircraft that you could talk to, verbally converse with without having to fiddle with devices to ask, like, this looks a little weird to me. What do you think about that? And it has access to maybe some kind of model or system to go and analyze the data and provide some kind of thoughts based on, maybe what's going on in the engine and the sensors available to it. Maybe it can make some recommendations or something like that. Maybe it can suggest an appropriate airport to divert to if you need, like, hey, I need an airport, my airplane and the performance capabilities of the airplane. Find me a runway that's not too short, that has services available or something like that, that has good weather and so forth. So I think something like that could be pretty cool, especially if it was kind of seamless for the pilot to integrate with. It doesn't take over for the pilot and those responsibilities, but it's an aid, and treating these tools as an aid to the pilot, I think would be pretty cool to be able to experiment with,
I like your idea on the first one, because a lot of times we think about the AI as something that has to be better than the best human,
Right.
and it's going to be hard for the AI to be better than the best human. But if you think about, if you're in the air and you're having some kind of either an emergency or some kind of urgency situation where the pilot is stressed and they have to do some deductions of some mechanical stuff that they're probably, let's face it, most pilots are not like super duper familiar with the details of their systems. Like, they might know the systems and how they work, but they're not able to troubleshoot things in their head quickly while an emergency is happening. So having a partner that you could, press the AI button, the PTT button, and ask a question, even though it may not be the perfect answer, it still may be a lot better than what you're able to strain on yourself in a stressful situation. So I'm kind of intrigued by that. That sounds kind of
It
cool.
sounds like R2D2.
Right.
Where Luke
that's
is
what
yelling,
we could call it, right?
R2!
Yeah. Yeah.
Right?
Right.
I need you to shut off the thermal capacitor coupler.
Exactly. Right. Yeah.
There's another side to that, though, which is kind of interesting, and it's a real challenge, I think, to when you're trying to put these tools inside the aircraft, which is the false positive problem. So here you are in the clouds, cruising along, instrument flight plant, dealing with all the stuff you have to deal with, and some alarm goes off. Well, as a pilot, that's a scary thing, and it's distracting, and so that could cause its own problems of being distracted by false positives. So, I think it's a great, it's a great concept. I think it's just we have to figure out how to solve that problem.
A question that brings to mind is the aviation industry has an absolutely stellar track record, despite what the media may represent. When a plane goes down, it's a very rare occurrence once you consider it statistically. And you went back to when you were talking about with 85% certainty, you can identify that a piston or a valve is under some kind of heat distress, right? In a situation like you just described, where an alarm's going off, something's happening, what's the level of certainty that would be acceptable for it? Like, so something's happening, you ask R2, what do you think this is, right? While you're flying, is it 85% good enough if R2 comes back and says, I'm pretty sure it's this, but my confidence is only 85%? Or do you have to get something that approaches 99% in a situation like that? Because getting to 85% certainty is a lot different than getting to 99% certainty.
Yeah, I think my thoughts on that, echoing what Chris said, is that we don't want to cause distraction. So if the pilot has the situational awareness to consider something.
Mhm.
The other thing to point out is that if you have this kind of digital engine monitor technology, most of them are equipped with alarms and all kinds of bells and whistles already, to alert you to problems. So if a temperature gets too high or a pressure gets too low or something like that, it will get your attention already. So
Mhm.
there's some basic level kind of alert functionality to built in. And I don't think we necessarily need to replace that. But this specifically would be like you're flying in the clouds and you notice that something doesn't look right to you, or, we're always skeptical of problems that could occur. It seems like the farther you are from an airport, the more skeptical you become, maybe. But if you could, as the pilot, initiate, hey, R2, what I see that, cylinder number 3 looks a little bit warmer than it typically does. What do you think? Something like that. So it's not trying to replace the pilot from in an emergent situation, doesn't necessarily add distractions. Or we try to avoid that strongly, but the pilot is still kind of in command of the aircraft, and when they're at a place where they can make those assessments and questions. And that's why I think the pilot initiated part of it is really important, because as a pilot, if like things are flashing, it is distracting, right? And we don't want to make things worse for the pilot, but we want to give them tools where they can assess kind of as they have the capability to do so, given their
So in that situation
bubble.
where all of a sudden you've got a valve that looks like it's a little bit hotter than it should be, is a valid use case to say, hey, R2, is there any history of this? Do you see any trends in the data that would that might make you think that this is a real thing and it's dangerous right now? Is that the kind of use case you're talking about?
I suppose so. We'd have to find a way to have the data at the
Right.
at the fingertips of the system that's making those assessments, which might be challenging. And this whole conversation is sort of device agnostic, I guess. So
Yeah.
that makes it another challenge, because we're talking about airplanes that have digital engine monitors that were built in like 1955 or whatever. So the technology on board might be very limited.
Mhm.
In my mind, like if, as an instructor, like I should probably project this. So like if you're flying an airplane, what I try to teach to students is like, if there's any doubt, right, there is no doubt. You should take appropriate action, land the airplane, declare an emergency if applicable, try to just get safely on the ground and figure it out. And that's why I think like tools to help the pilot out of the situation rather than fix the airplane in the air, because really there's not much you could, maybe you could reduce the power to cool the temperatures or, those kinds of things. But really what you want to do is, if you find something that's wrong, is get yourself out of that situation as quickly as possible. And I think that, tools that have access to things like runway databases and, traffic and weather and things like that, that's a more direct application, because that's something that the pilot has to consider irrespective of what the problem is. What's the closest airport with good weather that has a suitable runway that I could go to right now?
No MCP servers though. The AI is not allowed to just take the controls over. And
well, that's a really good point, actually, because they have these features in airplanes now that, you press a button and the airplane will go to the nearest airport. It will alert air traffic control. It will land the airplane totally autonomously, right?
Really?
Yeah, that box costs more than my last airplane.
Exactly.
That's a different story.
Exactly. And this could be easier to implement without all the additional servos and stuff to move the airplane. You're still flying the airplane. You're just asking questions.
I was going to take it one step further and kind of expand this from just maintenance and think, could you have this set up to your flying so it can detect abnormal things? So you can say, hey, I notice you're flying a little too slow compared to what you usually fly at 5,000 feet. Are you sure you're not setting yourself up for a stall spin here? Or, hey, I notice your angle of attack has been creeping up at 12,000 feet. Can you just maybe check for icing, because like something is funky is happening here? That could be. I mean, I know distracting, but like I also know in general aviation, we do have a lot of accidents from like pilot error. So like if the AI is able to kind of prod at the right point in time in the right kind of way, that could be interesting.
That becomes almost.
I had it experienced the other day. Look, make a confession here. So I was taking off in my aircraft, which has
filed a NASA
retractable.
form already, Chris?
I didn't do anything illegal, but my little instrument that tells me cylinder head temperature started flashing that I had. It was a warning that my cylinder head temperature on number 4 cylinder was high. And so I've taken off, I'm climbing. I saw that and it distracted me. And I knew, okay, it's going to be okay. It's mixture rich, and put the nose down a little to get the air over the cylinders. But a minute later, I noticed I wasn't climbing very fast. And I thought, I forgot to put the landing gear on. So that distraction, it interrupted my flow, and I forgot to put the landing gear up, which was not such a big deal, but it could have been, right, if it were something different.
Yeah, usually it's putting it down that gets people, but
that's
also probably a good idea.
Those are the ones you don't
But
hear
I
about.
think those are
right?
instances where the AI would be really good at it, right? Because right now, my airplane, if you didn't put the landing gear down, it had some really dumbass system to figure out, like, okay, if the flaps are not down and if you're like descending or ascending, it was really stupid. And I think even if you had some basic information from like the GPS, you could, with a 99% certainty, detect if the gear should be up or down, right? I'm in the vicinity of an airport, and
Sure. And it could have
within a mile
alerted
from
me,
it, landing
right?
gear should be down.
It could have alerted me that I'd forgotten. And, that would be helpful.
Yeah, I've seen a few apps and services like that do sort of a similar thing but it's all after the fact, right? So you upload your track log data and it will detect, what maneuvers you did and what you were doing. It will give you a score, basically, things like that, to make suggestions about pilot technique. And, there are other apps that have checklists built in that you can you press a button and it'll speak the checklist to you, which I think is pretty cool. But, like having something that you could kind of program to know your specific flow of the airplane, which is similar to that kind of thing, that would say like, oh, I've seen that you've taken off. So now you're at this altitude, check flaps up, gear up, hour airspeed, mixture, lights, those kinds of things. I think, something like that would be really cool and probably would not be too technically difficult to pull.
Well, and then that goes to the same way that we speak about, like, is ChatGPT making us stupid when it comes to writing because it's going to be doing all our writing? Is at some point, do I need to put the gear and the flaps up? It's like, hey, dude, I'm taking off. Just do your thing. I'll just watch over to make sure that things are happening. But like,
well, you got auto land, why not auto takeoff, right?
Deal with it, right?
What's riskier?
Yeah.
Taking off or landing?
Oh, that's a good question. I think statistically, probably they're more. Well, I don't know. I shouldn't say. I don't know off the top of my head, but they're both critical phases of flight for sure. That is absolutely
getting off the ground and getting on the ground. Not too fast.
I was going to say it's takeoff because usually most bad things happen when you're taking off and you don't have speed
anything near the ground.
Altitude.
Right. Near the ground, or
What's the
that's
most
where all the other
dangerous
airplanes
part?
are.
100 feet off the ground.
Well, driving to the airport, I think, is
it
a
is
joke,
actually.
Fair enough.
That's probably true.
Fair enough.
All right, so probably, and I think we're coming up on time, but I am curious about something. None of the LLMs that I use on an hourly basis are in my house, right? And as a matter of fact, there's a significant amount of bandwidth that is dedicated to making sure that I can talk to that LLM or that AI in some capacity. In all of my flying days where I am a passenger in the back of the airplane, I've noticed that connectivity to the internet is often a challenge. What does that look like in private aviation, right? Like, do y'all's planes have a persistent connection to the internet? And if you don't, how do you overcome that challenge if you know that you can't do all the computation on the plane?
There's a couple ways.
No one has you covered.
I'm gonna label this as dumb questions from the guy that walks on the ground.
Yeah, well, so how do you connect to the internet when you're on, you're flying Delta or something?
I don't know, because it seems to be really bad. I know that
Poorly, yeah.
I know that there's been various techniques where they've used satellite internet. There are times I've seen people use cell towers, where certain cell towers can project the right direction. I know Starlink is a current thing, but is that common on a plane, on a private plane? And if it's not, is it hard to make common on a private plane?
It's just recently people have started putting these newer small Starlink antenna in light aircraft. It's pretty new, but I think that's the way most people are starting to do it. I mean, in all the years I've been flying, your only connectivity to anything was your radio, you know. And Thanos, you may not know this, but also our founder, Mike Bush, he has a ham radio in his glove compartment on his aircraft. So he used to like do ham radio with it. But anyway, that was his second connectivity. Yeah, but I think Starlink is starting to be the way to do it.
Yeah,
Yeah,
there
I
are certain
wonder if we
like
did that, they would probably have non-connected systems, right? You probably want to train a small AI engine to
Right.
do your thing on board, so you're not relying on it.
Are you going to put the maxed out Max Studio on your plane and run DeepSeek? Is that the entire model? You guys hear about that?
Yeah,
Probably
running on a
optimized
Raspberry
around
Pi.
GPUs.
Oh God, no. No, something about the memory the memory architecture that Apple has means that you actually can run the entire however many billion parameter, like 400 plus billion parameter DeepSeek model on a maxed out, like in memory maxed out specifically, Max Studio with an M4 Pro Max chip or something like that. So, of course, those are like,
I have a Mac Studio with not maxed out memory, with some reasonable amount of
oh, yeah,
memory, and
it's
it
expensive.
was like if you ran any of the LLMs on my Mac, like it would just start crawling and eventually would just crash and
Yeah.
die.
Well,
So
I think that
it was not a good
that
experience.
studio, I think it tops out at like 26,000 or more dollars. So I mean, this is not.
You know, I
well, now
definitely
you're
did not
talking
have
airplane
that
money,
one.
right?
I was
mean,
gonna
this is
say, yeah, like
that's
Right, yeah.
airplane over. That's
So does it take that much for inference, or is it
it's inference.
training that takes all that
It's inference, yeah,
for inference?
yeah. It's
But that's like a gazillion parameter model.
Mhm.
It's not like a
oh
small
yeah,
thing.
no, and you
Yeah.
you can run much smaller models. So like I think I've run Llama 3 at 70 billion parameters on my gaming PC, and it wasn't fast, but it worked. And you can actually run much smaller models on most Macs and probably most PCs, even if they don't have a GPU. But at that point, you're talking about 12 billion, 20 billion parameter models. But
How about my Apple Watch? What can I run on my Apple Watch?
I actually don't know, and maybe we should find out.
I think that's a topic for our next episode.
It's like- so yeah, for what it's
I
worth.
have a burnt wrist for
Can
some
you hack
reason.
your watch?
Yeah. No, honestly, that feels like a YouTube video that goes viral that nobody will ever actually do, but just the fact somebody decided that they wanted to see if they could do it.
Well, it has to melt at the end, or else it's no good.
It did reduce the battery life to 5 minutes, but I can run the model. It'll actually utter 7 words. So, anyways. Well, anything else, guys? This has been great.
no, it's a cool topic. It's definitely an interesting field to be in, and it's been an exciting thing to be a part of. No, it's cool. It's very cool. Thanks for having us.
It's really fun because the airlines have done all this stuff. I mean, they're way ahead of the world we live in, which is general aviation. But Adam and I get to have a lot of fun because we're pretty much the only company that's doing this in the general aviation, like light aircraft owner flown space. So anyway, we get to have fun with it.
My
Yeah, there's some incredible stats, Chris. Like 9 million flights and a few 100,000 borescope images. There's some insane numbers there.
Yeah, we've got 9 million flights of data, which lets us do some fun stuff.
Yeah, the data's the hard part for all of AI. So I will say one of my ultimate life goals is to get my pilot's license, but first I have to not support my 3 teenagers daily. Very expensive. Daddy, can I get some gas money? Just hold. This could be my airplane.
Yeah, wait till you get to airplane gas money. It's a different order of
Yeah,
magnitude.
I might have to wait on that one. So, Awesome. Well,
But I know some flight instructors I can hook you up with, so say the word.
let's go. Let's go. And with that, humans of Earth, thank you for riding along with us on this new AI airplane. It has been a pleasure, as always. My name is Michael Rollins, and I am joined by my co-host Thanos, he of the Snapdom. And this week, we have been joined by both Dr. Chris and Dr. Adam from Savvy Aviation. Have a lovely, wonderful day, night, or whatever.